Hello, my dear friends. Hope all are doing good. And I am here with another useful project using Arduino and energy sensor. So, in this project, we are going to give a load protection against overvoltage, undervoltage, overload, and power factor variations. And all these electrical quantities or the parameters also can be displayed in the LCD display. So, let us see how it is being achieved. So, this is the wiring diagram of our project. So we have transformer, selector switch. So we have a transformer, so a step down transformer. We have a selector switch, a relay module, and we have a LCD. We have Arduino Uno, current sensor or a current coil, and we have a control switch and load. So let us see how it is getting connected and what are the function of each component. The transformer here, we are not going to use this as a step down transformer. Instead, we are going to use this transformer to give the different levels of voltages. Using this transformer, I am going to get different voltages as shown here. So I may get the 220 voltage what I am giving from the supply, that is a distribution company what they are giving, that supply 220 same as like that, or it can give plus 9 volt of the supply unit because this is 909. So 220 plus 9, so 229 can be achieved, or 220 minus 9 you can get 211. So this is the numbers. So this number may vary in your supply. So you may get 230 or you may get 240 volt as a input supply. So this is just for a numbers. Okay, so if I get 220, I will get here 220, here 229 and here 211. So based on the input, right? Now, how this is being achieved, I will give a separate video for that. So it's a property of a transformer, additive property and subtractive property. So using that property, we can achieve these different voltage levels. Right. So once we achieve this voltage level, I am going to set this 220 voltage as my normal voltage or a normal operating voltage, 229 as my over voltage, 211 as my under voltage. So again I tell you, so these are not just a numbers, it may vary with respect to your supply inputs. Right. So here I have the energy sensor where it needs the current input and voltage input of the supply or to the load what we are giving. So the same needs to be connected here. So that means whatever the selector switch output which is going to the load, the same thing will be given to this energy sensor as well. The potential will be same, and the current coil will measure the current which is going to the load here, which is going to the load. The current coil will measure and it will give through this path. So that means you get a current input and voltage input. So based on this current and voltage inputs, so this energy sensor is going to measure, or it is going to give the input to the Arduino Uno about the measured input voltage, input current, phase angle between them, power factor, energy, power, frequency, and also power factor. Everything, all the electrical parameters will be given to this Arduino Uno. So we need to write a code to obtain these values from this energy sensor, and these data will be transferred in this RX TX pin. So we have RX and TX pin which is connected to Arduino Uno. So I am going to use a sock serial, so that's why I am using 12th and 11th pin of Arduino. So if you are using hardware serial, so you can use this TX and RX pin of the Arduino Uno. Right. So this is the function of this energy sensor. Once I get the current input and voltage input, I can compare with my standard set values. So if I set 220 as my normal voltage and 229 as my over voltage and 211 as my under voltage. So based on that, this Arduino Uno is going to give the output for the relay to turn off and turn on. So if the voltage is at a normal state, so the relay will be in on condition. So that means the electrical supply which is coming from the transformer and from the distribution supply will be given to the load, so through the relay. So here the input is coming to this relay here and it will be transferred here. It will go back or go to the load using this control switches and to the load like this. If the voltage exceeds the normal voltage, that is say for example 229 or above, then the Arduino Uno will give the signal to the relay to open the circuit here. So the circuit will be opened here so that no power will be transferred to this load. So the load will be isolated from the supply. In the same case, if you are having an under voltage, when you have a 211 voltage for this case, so the Arduino again will give the input signal to the relay to turn off. So the Arduino is getting this voltage from the energy sensor. So based on the values we set in the code, based on that and the input what we are obtaining from the PZ EM004, compares these two values and it will open the circuit. Similar to that, for the current values also. So how much current you require, so we can set in the code. Suppose 1 ampere or 0.5 amperes like that. So based on that, this will open the circuit. Okay, so this is how the overall circuit functions. And here the LCD will be displaying all the parameters. In a normal operating condition, voltage, current, frequency, power factor, everything will be displayed. Under faulty condition, it will display what is the type of fault and how much current or how much voltage come across during that fault. So that will be displayed. Until otherwise you reset, the system will be in off condition. So this is the overall idea of this project. So let us go to the code part. So where we have the program. So this program already I have explained you in the other video which I explained the energy sensor. So the same code, I just added some if else condition and while loop so that I can compare the values with the standard values so that I can switch on the relay or switch off the relay. So those who would not watch that energy sensor video, please watch that video so that you can understand that one. So I don't want to repeat the same thing again and again. So here we have the header file for the energy sensor, and these are the software serial pins which I am going to use it for communication between the Arduino and the energy sensor, 11th pin and 12th pin. And so that is what I am declaring here. This is for a liquid crystal. So since I am using a backpack, a I2C backpack, so I have a header file and it is a 20x4 size LCD. So this is what it is. And I am going to declare a relay, so which is connected in pin number 10 of Arduino. So in a setup, I am going to begin the serial port communication and LCD. I am going to set cursor at 0 and I am going to display initially power meter. And this 10th pin which I have connected to the relay is going to act as a output pin. Now in the loop, I need to first switch on the relay so that the power will be available to the load. So first line I am writing digital write 10th pin, that is our relay pin, will be on. So since the relay is of a PNP type, so we are keeping it as a low so that it will be getting on. So if it is a NPN type of a relay module, so there you will use it as a high. So now it is a PNP type, so that we are using it as a low. So if you are having a relay module of a NPN type, so this low you can make it as a high. Then now our objective is to get all the electrical parameters of the supply or the load. So In this header file, we have all the functions inside. So this include PZEM004. So this header file contains all these functions. So once we gave the physical connection and we declared the wirings, so it will check the available voltage in the energy sensor. This PZEM0 PZEM dot voltage off. So this is a function which will obtain the value from the energy sensor, and it will bring to the Arduino, and it will store in this energy in this storage location, memory location. So this value will be compared here. If you have a value here, so that means it will print the value here. If there is no value, that means it will print as a error reading voltage. So there is no voltage, so it will say error reading voltage. So you can display here anything. So there is no voltage or no supply, something like that you can display here. And similar to this, you will have a current function. So PZEM dot current off. So these will bring the current value, and if there is a value, it will be printing in the serial port. If there is no current value available, so it will say there is an error in reading the current. And similar to that, power, energy, and we have a frequency and power factor. All these values will be bring from the energy sensor to the Arduino, and these values will be stored in the respective memory location, like frequency and power factor. All these memory locations will have its own values obtained from the energy sensor. So once we got all these values, we need to compare the voltages required to say whether it is normal or over voltage or under voltage, and for the current it is a normal current or over current. So we need to compare them. So this set of instructions is to compare. So if voltage greater than 230 and less than 245, okay, so since my supply voltage was near to 232 in a normal condition, so I have taken it 232. So 232, 245. So again, as I told you here, so your operating voltage or the supply voltage, how much you get. So based on that, you can set these values. So these are just numbers, you can play around with it. So this, if this condition satisfies, so it will display all the electrical parameters, and the load will be activated. So the load will be operating now. So it will display the voltage, load voltage, and then current and power factor, power, energy, all the electrical parameters will be displayed. If this condition not satisfied, if this condition not satisfied, then it will come to this voltage less than 230. So that means it is a under voltage. So when this condition, while and voltage less than 230, so when this condition is satisfied, then the relay will be off. You can see digital write 10 comma high. So that means the relay will be off, and also it will display the voltage. How much is the voltage? Less than 230 means it may be 210, 220, whatever the value obtained. So that will be displayed there. And similar to that, voltage greater than 242, so that means it's a over voltage. So these values, again, as I told you, these numbers can be of anything. So as per your supply input, so you can keep 260 or 255. Okay, so based on the standards. So now I said 242. If it is greater than 242 voltage, then of course what will happen? So it will compare with the set value and the input what you obtain. So if it is the voltage is greater than 242, then it will display over voltage, and also it will display the voltage value there, and the relay will be turned off. So relay turned off means that load is isolated from the supply. And similarly for the current greater than 0.5, I kept here 0.5 because my transformer is only of 1 ampere, so I am just limiting into 0.5 amperes. Okay. So since I have a transformer here, so there is a limitation. If you are implementing this project in a real time, so no need of a transformer, because you are not going to simulate. You are going to protect your load from the actual load variations or actual supply variations. So you need not to have a transformer. That time you have any limitation. You don't have any limitations. This energy sensor can measure up to 100 amperes of current. So you can use this device or this project for whole house. If it is a medium to small size house, you can use this particular project for protecting your house from house or your shop from electrical supply variations. 220 volt, if it is less than 220 volt, it can give indication, or if it is lower than very low value, so it can switch off power also. So in that way you can protect your loads. Mostly in our home TVs and fridge and all those things are getting repaired because of sudden voltage increase or decreases. So this project can help to avoid all these things. So this current, if it is greater than 0.5, as I declared here, so it is going to turn off if it is the current is load greater than 0.5, and also it will display it is a overload condition. Similar to this, I can write for power factor also. If the power factor is greater than, or I can say less than 0.9, so it can turn off the power, or it can send a message to the supplier or a consumer. Okay, so and also frequency variations, the frequency is decreased to less than 45, 46, something like that. Usually it will not happen, frequency mostly it won't change, but in case if it changes, then it can give the indication as well. Similarly, you can write a loop for compare function, so that it can give the protection for frequency as well as for power factor. So this is the implementation. I want to make it compact, so that it looks like more wires and all those things connected. But you see here, actually in real time, this transformer is actually not needed. The selector switch is actually not needed. So only the other few parts are required. So these are loads which is going to be away from your control unit. So it is not going to be a big complicated project. It is a simple project, and using our wiring diagram, you can easily connect them, and you can check this project as well. So this selector switch, we are going to see here the off position, normal voltage condition, and under voltage condition, over voltage condition. I have three switches to operate these three different loads. So based on the switch operating condition, these loads will be getting on, and the transformer which I used here for getting the different voltage levels are here. The relay module is here to turn on or turn off the loads under normal and abnormal conditions. So this is my energy sensor, and this is my current coil. So let us see how it works. So this is my normal voltage. I have not turned on any load. It is available normal voltage. I have 230 volt, 232, and I am going to turn on the loads now. We can see. Okay, so you can see now the load is turned on. We have 230 volt, 0.25 amperes current, and this is 60 watts lamp, so it is approximately near to 60. Power factor is 1 because this is an incandescent lamp. Frequency 49.9. So we get all the electrical parameters now, and it is displayed in the LCD. Now I am going to keep it in a under voltage position. So this is my under voltage position. So now I get 227.4 as I shown in the code. Anything less than 230 will be considered as under voltage. So this is under voltage condition. So the relay is turned off the lamp. So the switch is still in on condition. Here the switch is in on condition, but the lamp is gone off because the voltage is less than the set voltage limit for under voltage. So I reset this. I am going to demonstrate for over voltage now. I kept it in over voltage condition. So now the voltage is 242.9. So as I told you, I said I get 240 as my limit. Now it is 242.9. So it shows as a over voltage. So now I will demonstrate the overload condition or overcurrent condition. So now 260 watts lamp is getting turned on. So the current will be higher than the set value. So both lamps are got off and the current is more than 0.5. So it is turned off. I again reset it. So now I have two lamps. One is CFL lamp and another one is an incandescent lamp. And the current what you are obtaining here is 0.31 and the power factor is less than 1. It is not exactly 1. So 0.98 because of this CFL lamp. Now all three lamps are getting on. So now the current what we obtained through all three loads is greater than 0.5. So overload condition it turned off automatically. So now you can see I just switched on only CFL lamp. The power factor is 0.6. So this power factor is not actually acceptable in any supply system. So you should have, I think in many places we have 0.8. In some places it is should be greater than 0.9. So based on the standards, you can set the value here. So here 0.6 is not acceptable. If you have a while loop for this, it will turn off for this condition as well. So that's it for the implementation. Thank you. Hope you enjoyed this project. Try to do it. If you have any doubts, please let me know. I will help you in clarifying the things. And in case if you need the code or something like that, put your mail ID in the chat box. I will send all the code and everything to you so that you can implement this project. Thank you. Thank you so much. Let us meet in another useful video.